Hello, welcome to another video on describing continuous distributions. In the last video, we talked about visualizing distributions using histograms. And in this section, we're going to talk about a couple of things. One, what happens when you're collecting data over time so that there's really a time record or a time dimension to the data. In the second, we'll introduce the idea of the joint distributions of random variables. That is, sometimes two variables, and we often use the word correlated, sometimes incorrectly, but they're related in somehow. So in some way, when one variable changes, the other changes in relationship to it. So I'm not going deep into it in this video, but I will introduce the idea. So to introduce the idea of what we call run charts, I'm going to go back to the quincunx, which I sort of like as a teaching tool. And again, we have the funnel centered at 16, so I drop a series of beads. Well, keep in mind, there is actually a time order. It may not matter since this is a stable process, so I'll just drop a few beads, and then we'll look at a plot of the drops over time. So you're looking at basically what's called a control chart. You don't need to worry about that. Let's just call it a run chart. And you can see that the drops are just sort of bouncing around. Okay. Well, let's reset. And I'm going to display the chart right from the beginning. Okay. So I do a few drops. Okay. And then, what if I decide the funnel moves, or I decide to move it? So I will move the funnel, let's say 4 units to the right. And then continue to drop beads. So when you look at it, if you look closely, you can see it looks like maybe there had been an increase, but it's difficult to actually tell unless I keep dropping beads, and then eventually you'll see that the beads are now averaging a position of roughly somewhere around 20, which they should. If you just look at the chart, right around 20. When I started out, in the very beginning, they were averaging around 16. So when we use the run chart, it can help us see if something changes in a process over time. Okay. So the time order is important. And I'll also show a histogram. Now, we don't have a lot of data, but in the histogram, you can actually see the drops. In other words, you'll see the average, okay? And that which is really, since there's one drop, it's just the actual value. It's really hard to tell. It's a little easier to tell from the run chart because it looks at the run or time dimension or run dimension. A histogram just lumps the observations together and ignores time. So I'm going to go ahead and go back to the notes, and I'm going to go on to a slideshow at this point. Okay. So run charts, basically, if you have data, you have the time order or time record, you should plot it over time, and the run chart is a simple way to do it. The reason being, a histogram looks at the distribution, and it's assumed that that distribution really hasn't changed over time. In other words, it's assuming you have a stable or in control process. There's just noise or common cause variation present. So just forming a histogram of your data when you collect it over time without realizing it, you're making an assumption that this process is indeed stable. However, it may not be, and one of the ways we can tell is to just simply plot it over time, and we call it a run chart. And run charts can be done in JMP in a couple of places. I'll show you in a moment. And I'm going to start with an example. This is a car I used to own, a Subaru Impreza, and I used to track the gas mileage in the car. In fact, I still tend to do it. And here is a histogram over a 3-year period of gas mileage. And notice it's mounded, okay, has a peak somewhere between 31 and 32, and it's slightly left skewed. Okay. However, I'm ignoring the fact this data was collected over time. So what happens if I plot it over time? Notice there's lots of patterns going on in this data. In fact, you'll see basically there's a cyclic behavior. So, and by the way, that is real. Gas mileage, at least in cold climates, does have a cyclic nature. It tends to be at its lowest in midwinter and its highest in basically midsummer. But you can see none of this behavior will show up in a histogram, because a histogram just takes all the data, forgets about time, and just lumps all the observations together. So if you've collected data over time, the first thing you should do is plot it in time order to see if there's any important information. What this chart is telling me is the distribution of gas mileage values is not stable. In other words, there is a seasonal pattern to it, and there do occasionally appear to be shifts. Okay? And notice on 2 consecutive fill-ups, we went from the highest possible gas mileage that was achieved. It's not the highest possible, the highest that was achieved, and the lowest. Okay? What this turned out to be later on was a data entry error. Okay? But it just shows you that by plotting over time, I can see these very unusual patterns occurring, and then I can investigate them. Okay? So let's take a look at JMP. And look at the Impreza data. Okay. There's quite a bit of data in here. Notice in the columns window to the left, I have set date as a label column, so you get a little tag. So if I click on any observation in a plot, okay, it will give me what the date is. Okay. So let's say we're interested in miles per gallon. Okay. So one thing you might do is go to the distribution platform and plot MPG. Okay. And you get a histogram. And the average gas mileage is about 30.68 miles. But again, this histogram tells you nothing about what's really going on over time. And when we plot it over time, we see that the distribution isn't even stable. It's changing with the seasons. Okay. So to do a run chart, go to the Analyze menu, the Quality Process submenu, and then you can either go to Control Chart Builder, which is just a drag and drop interface. In fact, we'll just show it, which is a really nice tool that they're constantly improving. So date is my label. It labels the points over time. And then I want to look at MPG. Okay. And later we'll talk about statistical process control. It's not our focus at this point. But what you can see is that indeed, just from the plot, this is not a stable process. Something is going on over time. And now I'll show you the other approach for a run chart. Go to Analyze, okay, Quality and Process, Control Charts, and select Run Chart. So in the Run Chart dialog window, date is the label, MPG is the process. Okay. And I can click on the report menu, and I want to show the center line. Okay. And again, you can see the patterns. If I go to any point, it'll give you the date. So this was June 22nd, and we had the highest gas mileage ever recorded. And then 4 days later, we had the lowest ever recorded. Okay. So because date is a label variable, okay, and if you label, and by the way, I won't do it here, but once you highlight a point, so there is the 29th. Okay, if you go to the data table, say for a point that you highlight, you can, after it's highlighted in the rows menu, you can permanently label it if you want a permanent label. Okay. So basically, as I said, what we can see is there are distinct patterns. A histogram would not show those to you. So when you collect data over time, it is a very good practice to first plot it over time and see how the distribution behaves. So if you see things shifting, trending, or cycling, it means the distribution for gas mileage is actually changing. A histogram can't show you that behavior because a histogram assumes that the data come from an in control or stable process. That is, nothing's moving around, the mean isn't moving or shifting. Okay, so I'm going to close the Impreza data. And this is all explained in the notes, how to generate the charts. So basically what we're looking for, if a process is stable, and I showed you this with the quincunx, things just naturally bounce around some mean. Okay? Or we might look for cycling or trending. Those are indications that this is not a stable process, that things are changing. And then I briefly wanted to discuss scatter plots, but we're coming back to this later on. And this just introduces the idea that sometimes we're interested in looking at the distribution of two or more variables. In other words, when they vary, do they do so in some sort of common way? And this will lead us to the concept of what's called correlation, a way of measuring relationships among variables. So we have a data set called weight, and I just want to show you. So this is just a simple scatter plot. Again, I think I'll just go over to jump and quickly talk about this. Okay. Whoops, I missed slideshow. There we go. So notice we're looking at weight and height in the scatter plot, and we see that there's an outlier. Fit Y by X is a platform you use when you want to compare two columns to each other. Distribution is one column at a time, and Fit Y by X looks at two variables or columns at a time. Okay, so let's go over to Jump. There we go. And open the data students. So I'm going to open the data file. There's a couple of versions in here. I'll see which one I want to use. Students. I'll use the one called students. Okay. These are actually teenagers. So I want to compare height and weight, and most people would agree that height and weight do have a relationship. So I want to plot them against each other. So that would lead me to the Analyze menu to fit Y by X. So I plot it doesn't matter which way you do this because this is not really cause and effect. Height is X, weight as Y. Okay. So we do a scatter plot, and a couple of things show up in the plot. Number one, you can see there is an upward trend, which you would expect. As people get taller, they tend to weigh more, but it's not a perfect relationship. And then also notice an outlier. In other words, there's an observation that's not fitting with the pattern, and we call those outliers. And this is someone who's 54 inches tall and weighs 196 pounds. And this tells us it's row 182. Most likely, this is an outlier. Okay, in other words, probably either the height or the weight have been recorded incorrectly. So I'm going to highlight it. And while it's highlighted, just right-click and select Hide and Exclude. In other words, I want to get rid of the point. It simply, there's something wrong with it. We'll come back and look at it later as an example and investigate. Now, every time you make a change to the data table, you need to update your report. And you can do this in the Script menu. So I opened up the Report menu, went down to Script, and said Automatic Recalc. And believe it or not, it has automatically recalculated the data, or I could just resize the graph. Another interesting question, I'll just introduce this idea to you. We've seen a pattern, we found an outlier, but does it matter whether they're males or females? These are actually boys and girls. They're somewhere around, 11 to 18 years old. Well, the variable sex is a nominal variable. So how could I display that information on my plot? Again, we're going to show this in the future, but often we have a plot like the scatter plot, and we'd actually like to add more information to it. In this case, I'd like to see which of the points are males and which are females. Here's a quick way to do it. Right-click in the middle of the plot, and it says Make a Row Legend. And it says which variable. So I'm going to pick sex for males and females. And I'm just going to pick some standard plotting symbols and click OK. So notice the plus signs are the males, the circles, open circles are the females. And when you look at it, to be honest with you, in this age range, it doesn't really look like there's any difference. Okay, so this is the basic idea of a scatter plot. We added the additional idea of stratifying it by a nominal variable because we're interested in seeing if there are different patterns. Okay, and this ends our discussion of run charts and scatter plots.